Okay, so for this video, we're going to take a deeper dive into the PicoScope 6 automotive software and some of the features we can use on it. I'm going to talk about setting the scope up for voltage scale, time base, setting it up for attenuation, looking at the waveform buffer, the rulers, the zoom features, and just go in more detail than we did in that previous video. And I do recommend that you guys download the PicoScope 6 automotive software onto your personal computers. It's a free download on the PicoScope website, and you can actually open it up like I have it here without an oscilloscope attached, and it's actually in a demonstration mode. So it just allows you to kind of play around, and even though you're not actually measuring a voltage and it's kind of just a demonstration instead, you can still mess around and learn some of the features of the program. So in this demo mode, it looks like they're trying to show us an injector waveform, and as we can see, it's jumping around erratically. That's what an injector waveform looks like. For some reason, the voltage level is low on this waveform. Normally this would operate at 12 volts, but anyhow, so what we're looking at on this screen is on the y-axis we have the voltage scale, and in this case it goes from 0 volts in the middle to 5 volts at the top, and then 0 to -5. So we have a plus or minus 5 volt scale currently for the voltage. And on the x-axis we have our time base. So in this case we have 5 milliseconds per division, and we can see that up here. This is where we change our time base. So 5 milliseconds per division. So we can see that each one of these divisions, or one of these boxes horizontally, is 5 milliseconds, or 5 thousandths of a second. So the whole screen then, because there's 10 boxes, is 50 milliseconds long in the whole screen. Okay, so before we go into some of the other functions of the PicoScope, I want to show you guys how to stop this waveform from jumping around all erratically like this, so we can take a better look at it. So we basically have two options. So the simple option is we could just pause the screen, like so, by pressing this red button, red square in the bottom left, and that'll pause the waveform, and we'll see that we can go in and do a deeper analysis of the waveform once it's paused. And you can press play with the green arrow to start it back up again. You could also use the space bar as a shortcut for this, pause and play. So another thing that we're not going to get too deep into, but I just want you to know it exists, is the trigger function. So what the trigger function does is basically when you have a waveform like this jumping around all crazily, it essentially tells the oscilloscope to draw the waveform at an exact point. So let me give you a quick example. So we're not going to go into depth, but I just want you to know it exists. So if we go to repeat trigger, and I have this on leading edge for channel A, it's right now at 1 volt. We can pull it up a little bit higher to make it better. So now what's happening is that waveform is reoccurring just like it was originally. It's each time the injector fires, it's reoccurring. However, I'm telling my oscilloscope to draw it once it hits this voltage level. And we can go into that more in depth in the future, but I just want you to know that triggering exists, and it's a common function we use. Okay, so now that we have the waveform a little bit more steady on the screen, let's take a look at the voltage scale. So like mentioned previously, the voltage scale is on the y-axis, and the blue numbers here correspond to the blue waveform. That's important to know because once we add other channels in the future making voltage measurements at the same time, the color of number on the voltage scale corresponds to the color of the actual waveform itself. So you can have them on different voltage scales, and that's how you can tell which one's which. So anyway, up here in this bar we have our 4 channels here, A, B, C, and D, and you can see they're colored differently. A is blue, B is red, C is green, and D is yellow. And these blue functions here all correspond to channel A. So as we can see, channel A is the only one that is turned on currently. It's on an auto voltage setting right now, but you can see that B, C, and D are all turned off because we don't have any voltage readings coming from them. So if we want to change the voltage scale for channel A, we can click this drop arrow here, and we could turn it off if we wanted to, but we're going to keep it on. Currently it's on an auto scale, so the scope will kind of automatically set the scale for you. However, I recommend manually scaling just for practice. So we're on a plus or minus 5 volt scale right now, so the whole screen is 10 volts tall, plus or minus 5. So let's change this to a plus or minus 20 volt scale. So now we can see the waveform shrinks drastically because the whole height of the screen is now 20 volts tall, above the 0 line and 20 below. So that's how we can change our voltage scale very simply. And you can see, so right now I made it plus or minus 200 millivolts, which is far too small of a scale. The waveform's much taller than that, and you can see we get this red exclamation point telling us that we're over range. It's not actually damaging anything. It's just that the waveform, it's warning us that the waveform is off the screen. Okay, so we'll change this back to plus or minus 5 volts. And the next thing I wanted to show you is some of the options we have for each channel other than setting the voltage. So another option we have is to AC or DC couple the channel. And just for our purposes, most of the time you're going to stick with DC coupling. AC coupling essentially just brings the center of the waveform down to the zero line, and it's common when measuring alternating current waveforms. However, for us, most of the time we'll just use DC coupling. And then here we have more channel specific options. So if I click on the A here for channel A, we'll get a menu, and that applies for all the channels. You can do it individually for each channel. But anyway, the first option is the probe settings. So this is where we can set attenuation, for example. So if we had a times 10 attenuator on, we could set it times 10, and you can see the waveform change there. And it actually increases the size of the waveform, the voltage, by a factor of 10 to compensate for that attenuator in there. So make sure you set the attenuation properly if you are attenuating, but we'll just keep it on times 1 because we're not attenuating. You can also do some filtering in here, so that's good to know. If your waveform's a little fuzzy, you can do some low-pass filtering. You can also set different presets for the current clamp, like the one I showed earlier in the video, and some other pressure transducers and whatnot. So this is where you select your probe settings in there. And then here I'll give you an example of turning another channel on. So this is again in demo mode. So now we can turn on another channel, and you can see there the red waveform. We have another channel turned on, so that's what it looks like if you have more than one voltage reading. And as you can see, we can drag these around to kind of move them out of the way. So here's an injector voltage and current, it looks like is what they're trying to show here in the demo mode. And the red voltage numbers here apply to the red voltage waveform. Okay, so the next function I'll show you is probably the second most important function on the scope other than setting your voltage scale, and this will be setting your time base horizontally. So if we come up to this menu right here where it says 5 milliseconds per division, we can use these quick arrows and change the amount of seconds per division. So as you can see, if we want to kind of expand the waveform, we can decrease the amount of time per division, and it kind of expands the waveform like you can see there. And now we're at 500 microseconds per division, so that's very quick. So there's very few time between each of these divisions. And then we can also increase if we want to see more waveforms per screen, like so. You can also hit this down arrow and select the exact amount you want. So there's seconds per division in this menu, milliseconds, microseconds, and all the way down to 500 nanoseconds per division, which is very, very quick. So that's how we change our time base horizontally. So another cool feature we have when we pause the waveform is we can actually go back in time and see screens of the waveform prior to the current one depicted on the screen. So if we go up to the waveform buffer menu, which is this menu right here that says 32 of 32, we actually have 32 saved screens of this waveform, and currently we're on the most recent one, the 32nd one. However, we can go back in time and go to the 31st, the 30th, and so on. And as you can see, it's not changing much here because the waveform was pretty consistent, but we can go back in time. And if we hit this compass here, it'll give you a visual depiction of the different screens if you prefer that way. And the menu next to the waveform buffer is the actual sample rate of the scope per screen. So in this case, it's doing 100K samples per screen, and we can actually change this around, and basically that just tells you how many times it's reading voltage per screen, because it essentially just reads voltage at each point and then connects the dots. So the more samples we have, the better the waveform will be, especially when we zoom in closer to it. The more accurate it will be to the real waveform in real life. So that's the samples there. So some of the other buttons we have is this lightning bolt, for example. This will auto set up the scale. So if you're making a measurement and you have no idea how to set up the voltage or the time base, for example, this will just kind of auto set it for you. I recommend trying not to do that, but that is what that's for. The home button here will bring you back to the default settings of the scope. So say, for example, you completely mess up your time base and your voltage and everything's looking all weird, you can hit the home button and it'll just take you back to the default settings of the scope, like when you first opened it, to kind of start at square one. So some of the other functions we have up here in this area are some of our zoom functions. So first off, the pointer, if we want to click anywhere on the screen with the pointer selected, it'll tell us the voltage and time at that exact point. So here it will tell us the voltage for channel A and B, as well as the time at that exact point. So that's kind of cool, so we can click at different areas and it will tell us that. Also, we have some zoom tools here. So if we hit this magnifying glass with the plus sign, we can zoom in at a certain point, like so. Or if we want to zoom in here, we can zoom in further. And it shows you down here in this box specifically where you're zooming in, what's on the actual screen compared to the full image, of course. And we can get out of this by hitting this hourglass, or magnifying glass rather, or exiting out in the corner here. I actually prefer this magnifying glass, as we can select a rectangle of a spot that we'd like to zoom in, like so, and we can zoom into that spot specifically. Say we wanted to look at this peak here, we can zoom very, very close in and then get out of it like so. And lastly, when we zoom in to a certain point, we can use this hand tool to click and drag around if you want to move around the waveform a little bit. That's what the hand tool is there for, and then we can get out of it again with this button here. So the next feature I want to show you is the notes and channel labeling feature. So we'll start with notes. So the notes feature is simply basically a little note section where we can add any little comments in at the bottom about our waveform. So for example, let's just say these waveforms came from a 2010 F-150. So I can write that in there at the bottom, and then that way when I save this waveform and maybe come back to it in the future, or if I send it to someone, they know what this waveform came from. And by the way, we can save these. Once you pause it, you can hit save as and save your different waveforms, so that's good to know. So that's the notes feature there. We also have the channel label feature. So this is more specific, so we can label our channels individually. So for channel A, say we want to label that. So in this case, like we talked about, channel A was injector voltage. So we can hit this drop arrow here and select injector voltage, scroll through there and find it, or we could just simply start to type it out. So if I start typing out injector, there we can see injector voltage. Then we can add any other notes here if we wanted to add any other notes about it. In this case, I'll just leave it empty. And then for the unknown part, so that is where we can actually select whether or not this signal for channel A is a good signal or a bad signal. So in this case, it's probably a good signal, so we'll call it good. And then that way, if I ever come back to this waveform in the future, I'm working on another vehicle with a similar waveform, I can compare good to bad injector voltage waveforms. So we know that this one's good. Then we can do the same thing for the other one. This is injector current for channel B. So I'll click on injector current here, and we also assume this is a good injector current waveform. And then once you have these, if you want to move them off the screen, you can just minimize them. So another little trick you can do is you can actually open up more than one oscilloscope screen, and this can be useful if you want to look at each waveform on each channel a little bit more separately, or analyze them a little bit more separately than having them on one screen together like they are right now. So how you can do this is you can go up to the Views menu, you can click Add a View, Scope. So now as you can see, now we basically have two oscilloscopes open, Scope 1 here and Scope 2 here. And what we can do if we want to just have one waveform on each scope screen is we can right click, we can go down to channels, and then we can unselect channel B for this top one, or sorry, this bottom one, and then for this one we can go to channels and unselect A. There we go. Now we have two separate scope screens with each waveform, and you can adjust these accordingly separately, and it just makes it a little bit easier visually if you prefer it this way. You could also adjust the size of each one like so. So up next I'm going to show you how to add some measurements, and we can actually do this one of two ways. The first way is we can go up to this Measurements tab and click on the Add Measurement drop down, or we can go down to the bottom here and hit the plus sign to add a measurement. And before I make any measurements, I'm going to turn on my channel C here and play it, because I want to do a measurement on a AC signal just to make it easier for the type of measurements I want to do here for the example. So here we have a crankshaft position sensor signal. This is a variable reluctance type AC signal, and that's the measurement, or that's the waveform that we'll be doing the measurements on for this example. So I'll pause it real quick. I'll go down here to add a measurement. Then this window pops up. So the first thing we have to pick is which channel. So I'm going to do it on channel C, this first example measurement. And then I'll do how about we do a frequency measurement. So we'll do frequency and we'll do it for the whole trace. So I just did that now. We'll play the waveform. And now we can see what's happening is the measurements posted down here for channel C, the name of its frequency, here's the instantaneous value in kilohertz, the minimum overall value since the recording started, and the maximum value since the recording started, the average, and then of course the span is over the whole trace. So there's an example of a one measurement we can do. I'll do another one. So we'll add another measurement here. Let's again do it for channel C. And this time let's do how about we do a maximum voltage measurement. And this time let's do it between rulers, just to switch it up. So we'll add that in. So now instead of measuring the maximum voltage for the whole trace, I have to bring out some rulers and it'll measure the maximum voltage between those rulers. So I'm going to talk more about rulers in a little bit. I'm going to drag out two of my time rulers here. So I want the scope to measure the maximum voltage between these two rulers here, for example. So now I'll play the waveform. You can see nothing's been really recorded yet because the waveform's not playing. So now that the waveform's playing, we can see the maximum voltage for channel C. The instantaneous value is about 3.45-ish volts. And then the minimum since we're recording, maximum since recording, the average value, and now we're measuring just between the two rulers. And that is how you make measurements, and you can add as many of these as you want to the different channels. We'll pause this here. And then in case you were wondering, if you want to get rid of a measurement, you can just right click on it and delete the measurement like so, or you can hit the minus button here and delete the other measurement. So that's how you make some measurements. So the last function I'll show you guys is the rulers function, and we actually have two types of rulers. We have voltage rulers and time rulers, and they'll measure voltage and time respectively. So to start off with the voltage ruler, if we hit this blue square in the top left, we can drag down the blue channel, or channel A, the blue channel's voltage ruler. So in this case, whatever height we put this at, it'll read the voltage. So in this case, the peak voltage on the blue waveform is roughly 2.827 volts. So that's the blue channel's ruler for voltage. Then we can do the red channel's ruler voltage right here with the red square, and we can measure it on the same menu up here. It reads 105.4 millivolts at this point. So those are your voltage rulers, and they're very handy. We also have time rulers, and those are down here in the white box, or there was this white square here, and we can drag that out and it'll read the time at this point. So in this case, the ruler is currently reading 99.73 milliseconds. We can drag out another time ruler, and the ruler 2, so there's ruler 1, and then ruler 2 for time is reading 216.7 milliseconds. And then the triangle stands for delta, which just means the difference between the two rulers. In this case is 117 milliseconds. So those are our rulers. Okay guys, thanks for watching. Hopefully you found this video informational, and hopefully you learned something new about the PicoScope software. Thanks again.